Hey everyone, Divyanshu here, and today I'm going to look specifically how quantum mechanics predicts the existence of two particular kind of particle, bosons and fermions. In the particle physics or systems involving elementary particles, the description of particle are made on the basis their features like mass, charge, etc. and their interactions with the other particles. We have to start from the wave function, and the wave function is the description of everything we know about the particular quantum system that we are going to study. And the quantum system can be made up of an electron, many electron, and a bunch of particles or something like this. So we can say that the wave function is a mathematical term that includes the information about the quantum system so that we can use it in our further calculations and observations. As well as there is a presence of a wave function square that tells us the probability distribution about the quantum system, which is much more important than the wave function itself. Now let us consider a system of two identical indistinguishable particles. Being identical and indistinguishable is not a similar thing. Being identical means that the particles are symmetric in charge, mass, and a number of things. But indistinguishable means, let us consider you have named a particle A and B. Once you stop your observation, even for 30 seconds, for 10 minutes, or for a whole years, you will not be able to define the particles as A and B as you defined in the previous observation, because both of the particles may interchange their places with respect to each other or not. You cannot be that much sure about it. So let us consider there are two places x and y where the particle can be in our system, in our quantum system. If the particle A is at the place or at the position x and the particle B at the position y, then the corresponding wave function will be psi x comma y. And let us consider if the particle A is at the position y and the particle B is at the position x, then we can say that the corresponding wave function will be psi y comma x. With the help of these two functions, these two wave functions, we can find the probability distribution for both of the conditions, and the corresponding probability distribution will be psi square x comma y and psi square y comma x. As we already know that the particles are identical and indistinguishable, then we can say that the probability density in both of the situations will be equal to each other. Then we can say that psi square x comma y is equal to the psi square y comma x. And now we can take a square root on both of the sides in the above equation. As you already know, once you remove the square root with the help of a square, there will be plus minus sign on one side of the equation. Then the equation will be psi x comma y is equal to the plus minus psi y comma x. Then we can break this equation in two parts, and any particle whose wave function behave like this is called boson, and any particle whose wave function behave like this is called fermion. Now you can say that the identical particles separate out differently because of antisymmetric and symmetric wave functions. We know that the ones dictated by antisymmetric called fermions and have Fermi energy, while the symmetric ones dictated by symmetric wave function are called bosons. The fermions were found to obey Pauli's exclusion principle and obeyed Fermi-Dirac statics, whereas the bosons obey Bose-Einstein statics. Popular members of fermions are electron, quark, neutrino, proton, neutron, and etc. And they are building blocks of the matter, whilst photons, gluons, Higgs boson, W, Z bosons are some of the bosons. So it was all about how you can create a difference between a boson and a fermion. And truly very thank you for giving me so much love. We'll meet in our next video. Till that time, keep watching, keep learning, stay safe. Thank you.